Good afternoon everyone. I am Chanda Devnath, one of the PMRF fellows pursuing my PhD from Aizar Berhampur. So I am the TA of this course, a study guide in organic retrosynthesis and problem solving approach. In these classes I usually discuss about some topics based on important organic reactions, and we also solve some previous year questions from NET, GATE and some important books, which through solving those questions you will get an idea about different type of name reaction and different type of reaction procedures, which may help you to plan a retrosynthesis of any large molecules. So let's start. In the previous classes I have already discussed about all these name reactions and many more which I haven't mentioned here. Then we focused on discussing different type of olefination reaction, like olefin formation reactions, and then we move to the reactions of olefin, like how the double bonds take part in a reaction, how we can functionalize any double bond. So in continuation of that, we will solve some previous year questions based on these reactions of olefin. Then we move to some remaining reactions to form any olefin or any double bond or triple bond, and we will plan to solve some previous year questions. So in the last class I have already discussed about the hydrocoordination of any double bonds, how this takes place. So based on that, can anyone approach this question? This question came in GATE 2008. So they have asked for which is the major product form in this reaction. So this is based on this hydrocoordination reaction. We have already discussed about this, the chemistry or the mechanism about this one in the last class. So we will try to solve this one. So you know that when hydrocoordination takes place, boron is added to the less hindered side and hydrogen is enter to the more hindered side. So the product will be, after the first step, and this hydrocoordination is always cis in manner. So if we just imagine this methyl group is above the and this total reagent is approaching from the below the plane. So there will be a hydrogen and this will be also the wedge bond. So they are approaching from the below the plane. Now after the second step, like the H2 to NaOH, the oxidation of this carbon boron bond, it becomes a oxygenated, keeping the stereochemistry of the carbon same. So the product will be option B. Product will be option B. What will be the major product form in the following reaction sequence? So this is after 3 steps. All this reaction we have studied. The first one is hydrocoordination reaction. Second one is PPS3 dead. Whenever there is a diethyl azurite carboxylate and PPS3, this is a Mitsunobu reaction. That is a Mitsunobu reaction. So if we just, after first step, there will be a hydrocoordination, next the similar way, and hydrocoordination followed by oxidation. So I am just drawing the product directly. If we keep this above the plane, then there will be a OH. I just did a step jump, as in the last question I have already discussed about how it goes. Okay, now in the next step they have performing a Mitsunobu reaction. In Mitsunobu reaction, what happens? We synthesize a ester. From acid we synthesize a ester. So here there is a alcohol and there is a acid. So there will be a esterification. Now, so there will be a esterification. But it always that in case of Mitsunobu reaction, you have to keep remind that mechanism. In case of Mitsunobu reaction, the reaction is always a SN2 reaction. The reaction is always a SN2 reaction. Whatever is the stereochemistry of the OH, the upcoming acid comes from the opposite plane of that one. Because this OH reacts with PPH3 and turns into good living group. I have already discussed about this Mitsunobu reaction. If you want to know, you can go and check the previous classes. So this OH will be transformed into a, now this is not a good living group, this is a bad living group. Okay, OH. Now in presence of PPH3 and dead, it becomes a good living group. It becomes a good living group. So the upcoming acid, that is at 4-nitrobenzoic acid. This R group is the 4-nitrobenzoic. It will come from the opposite plane of this one and it will eliminate. So the next it undergoes a hydrolysis. In presence of K2CO3 and methanol, it undergoes a hydrolysis and form. So see, what is the difference between this one and this one? What is the difference between 1 and 2? Just the stereochemistry of this OH group. Just the stereochemistry of this OH group. Here the OH group is below the plane, but here the OH group is above the plane. Like this way, if suppose you have a substrate which have a different stereochemistry of the living group, but in your product you have an opposite stereochemistry, in that case you can perform this Mitsunobu reaction. Okay, so the correct option is option A. The correct option is option A. What is the major product formed in the following reaction sequence? So this is a oxymercuration demercuration reaction which we have discussed in the last class. So how this reaction will take place? So in case of oxymercuration, this is the opposite of the hydroboration reaction. This is just opposite of hydroboration reaction. So this mercury will add to the less hindered side and hydrogen will enter to this more hindered side. Then this then let's do step by step first. It will form a cyclic intermediate with mercury. it will form a cyclic intermediate with mercury. Now after that, as this reaction is taking place in water, so water will act as a internal nucleophile, and this will approach to the more stable carbon. If this opens up from this side, the generating carbocation will be 3 degree. But if it opens from this side, the generating carbocation will be 1 degree. So obviously 3 degree carbocation is more stable than that of 1 degree. So that's why this center will attack here and it will open up. After that, in the next step, if you in presence of NaBH4, what will happen? This carbon mercury bond will be replaced by hydrogen. Moreover, this ester will be hydrolyzed, this ester will be reduced and form a alcohol. So the product is the correct option is option D. I hope it's clear. Let's go to the next question. What is the major product form in the following reaction sequence? Similar oxymercuration demercuration reaction. I just give 2 seconds. Just think for a. I just give 2 seconds. So similar way, it will form a cyclic cation with mercury. After that, the next step, as amine is there in the reaction medium, so here instead of water, amine will act as a nucleophile. Next step, now it's open up and this Hg bond is there. As there is no NaBH4 is given, so it won't be replaced by hydrogen, rather than Yes, but so correct option will be, or otherwise there is a possibility of after that reaction can't take forward, so there is a possibility of the correct option is option B. Next is the next way to form a elimination double bond is elimination reactions. So elimination reactions are a fundamental type of organic reactions where two types of groups are removed from a molecule resulting in formation of a double bond. So there are different type of elimination reaction: EI elimination, E1 elimination, E2 and E1CB. All these three have been may have been studied in your graduation. EI is bit not that much explored, but all these are much explored in your graduation basis. So I just give a short overview. E1 elimination means where the leaving group leaves the system. Suppose this type of system is there. This is the system leaving group. So E1 means it is a unimolecular reaction. That means in the first step the leaving group will leave from the system, and in the second step nucleophile will attack. Whereas in the E2 elimination this takes place simultaneously. Sorry, not nucleophile, I just in the second step H from the adjacent carbon will be eliminated and give us the alkene. Whereas in case of E2 elimination, this elimination takes place simultaneously, like if the H goes here and the leaving group leave from the system. This is called E2 elimination. And in case of E1CB, the base first take the proton, generating a carbon ion. Here, then this carbon ion will move to form the alkene. So see, you have to notice the difference, okay? In case of E1, the leaving group leaves the system at first, then the proton elimination takes place. Whereas in case of E2, the proton elimination and the leaving group elimination takes place simultaneously. In case of E1CB, first the proton elimination takes place, after that the leaving group leaves from the system. So these are the three differences. And the another one is EI. EI is bit different from all these three that we will discuss after that. So there are some questions based on these elimination reactions. Came previous year NET examination. For the following two reactions A and B, the correct statement. So what will be the product in A and what will be the product in B? You have to determine both the product. So if we just draw this cyclohexane in a chair form, it will be better to understand the stereochemistry, because all these bonds are loaded in a wedge bond. So that means the stereochemistry is in our concern. Whenever the bonds are drawn in a simple line, that means there is no consideration of stereochemistry. But if the stereochemistry has been mentioned in your substrate, that means in a product also they wants to know the stereochemistry of the adjacent bonds. So whenever there is a cyclohexane question, always try to solve those questions through a chair form, so that it will be better for to get a correct answer. So if we just draw this one, it is for A. In case of A, this is above the plane. So you have to place this anchoring group always in the equatorial. So equatorial plus above position is, this one is correct. You know, I think you know about the anchoring group. Whenever the cyclohexane moieties are very ready to flipping, so to hold the flipping so that it can't flip to the chair to another chair form, we always keep an anchoring group which stabilize the structure of the one cyclohexane structure of the molecule. So if you keep this group like this tertiary butyl group, it acts as an anchoring group, because if you keep this in above the plane, you have to keep this in this way, so that the above arrangement is remains, and also it always been placed in the equatorial group. I hope you know about all these things. So the bromine is above the plane, so bromine will be here. So always draw the anchoring group first, then draw other groups, and CO2 is here. Okay, let's draw the next one. In case of this part is same, bromine is above the plane, whereas CO2 is below the plane. This is B. Now in this case there is a proton available which is anti-peripheral arrangement. You know that in case of E2 elimination you need an anti-peripheral arrangement. So there is proton is available. So this will go here and this will be eliminated. And as the reaction is in tertiary butox, potassium tertiary butoxide, so our acid will be deprotonated and a salt will form. So it will be like this. So this, the correct option from here, you can see the correct option will be between A, B or D. A and C are already cut. The correct option will be between B and D. Now let's see what B gives. Now in here there is no beta proton available to eliminate this bromine atom. There is no such beta proton is available to eliminate this bromine atom. That's why what will happen here? In this case, in presence of base, this carboxylic group undergoes a decarboxylation, and through decarboxylation this bromine group eliminates to give us this double bond as our product. So the correct option is option B. Correct option is option B. I hope it's clear. Whenever there is an anti-peripheral H is available adjacent to the leaving group, then simple E2 elimination will take place. If there is no such anti-peripheral H is available, you have to think about other possibility. If there is any neighboring group, then there will be neighboring group participation. If there is any carboxylic group, then there will be a decarboxylation. What will be the product in this case? See, these elimination reactions are so important. That's the same question, exactly same question in GATE 2009 and June 2013. Exactly the same question. They just change the options, but the question is totally same. So that's to show that the answer will be same, obviously. So whenever there is a cyclohexane type of question, always try to attempt those through a chair form for a clear understanding about the stereochemistry. So the OTH group is above the plane and this OH group is below the plane. This OH group is here and this OTH group is above the plane. Now there is a H. This H is not anti-periplanar to this bond. From the drawing you can see this is not anti-periplanar with this hydrogen. So this hydrogen can't take part in elimination reaction. The only bond which is anti-periplanar with this bond is this carbon-carbon bond. See, this is totally anti-periplanar. Totally anti-periplanar with this bond. That's why this will take part in a elimination reaction. So when you add KH, that is a H minus source, it will take the proton from here and remove H2 gas. This bond comes here. So the product is be careful during pressing the double bond. You have to count the number so that there is two questions with the carbonyl and a double bond. So though no mistakes takes place. So just count the number. So adjacent to the carbonyl is 3 carbon apart. The double bond is 3 carbon apart. So this will be the correct option because this is 3 carbon apart. So the correct option is option B. You see from here 3 carbon apart, so the correct option will be option D. Okay. What will be the major product form in the following reaction? As you can see a leaving group and the product is a, so obviously there will be a chance of elimination reactions. So there is no anti-periplanar hydrogen with respect to this OTS. That's why you have to rotate this bond. The rotation along this single bond is possible because this is the carbon, so the energy is quite low. So if you just rotate this bond to keep, I'm just rotating this one, to keep the OTS anti to the hydrogen. We are keeping the behind carbon center same. The front carbon just rotated. So if H goes here, phenyl comes here, and methyl goes here. Then it undergoes the elimination, giving a product where the H and the pH is in the same plane, whereas two methyl are in the same plane. So the correct option is option C. Correct option is option C. Next one is EI elimination, which I was talking about. So this is also known as a thermal scene elimination or pericyclic scene elimination. It is a special type of elimination reaction in which two vicinal substituents on an alkane framework leave simultaneously. That means in case of E2 elimination, you always take eliminated the anti-periplanar group, that is which two groups which are anti to each other. But in case of EI, we remove two seen groups, with the groups which are seen to each other, that means at the same side, via cyclic transition state, and to form an alkene in a seen elimination. If you have remembered about the Peterson elimination, I discussed about this in I think in the last class maybe. There we know that Peterson elimination are two types. One is base catalyzed, another one is acid catalyzed. Whenever there is an acid catalyzed Peterson elimination, there will be a anti-elimination. But whenever there is a base catalyzed Peterson elimination, there will be a seen elimination. So this is that kind of a seen elimination. So this type of elimination is unique because it is a thermal activated, does not require any additional reagent, unlike regular elimination which require any acid or base, or would in many cases involve charge intermediate. This reaction mechanism is often found in pyrolysis reaction. So if you see, this is the substrate. There is a proton available here. As the stereochemistry is not restricted, so this oxygen will take a proton here, this comes here and it eliminated from the system. Using this as our product. Rest part will be same. I am not drawing it. Okay. So this is the mechanism. So there are different type of EI elimination reaction. First one, this ester elimination, where this ester group take a adjacent seen hydrogen and it get eliminated to give us an alkene. Next one is cope elimination, where this tertiary N oxide will take a proton from the adjacent and through a 5-member transition state it will give a alkene. And next is this hydrogen bromine bond. The elimination must be seen at the atoms coplanar for forming a 4 or 5-member transition state, but the coplanarity is not required for 6-member. So let's see what will be the correct answer for this question. So there is a hydrogen available here, so it undergoes a EI type of elimination. It comes here. Sorry. So there is a hydrogen available at the adjacent carbon. So this will take a proton here. So the correct option is next is this one. What will be the mechanism for this product? How this product will be formed? First, this ET3N will take a proton from this alpha proton and generate an enol intermediate. Next is this comes here. Next, selenium will be oxidized. Now in presence of H2O2 it will be oxidized. Now it will undergo the EI elimination, where if there is an adjacent proton, eliminated, giving this as our product. Okay, I hope its mechanism is clear. Let's go to the next one. What will be the product in this case? So first, let's do step by step. So first, this oxygen will attack to this phosphorus, forming a turning oxygen to OH to a good living group. Next, this selenium will attack to this carbon center and remove this, substitute this OH group. Next, the next step, as H2O2 is given, in the next step, as H2O2 is given, so this will be oxidized and it will take a proton from this adjacent carbon and give us this as our product. Okay, I hope you understood. I can understand the mechanism here. It will be oxidized. After that, it will take a proton from this adjacent carbon and it will give us alkene. What will be the product here? In presence of MCPBA, this dimethylamine will be oxidized, form a N oxide. So it will be oxidized to form a N oxide. After that, it will undergo the cope elimination. After that, it will undergo the cope elimination. It will take a adjacent proton which is seen to this. So there is a proton here which is anti to this nitrogen, whereas there is a proton here which is seen to this. So which proton will be eliminated? Obviously this one. So the correct option. So it will take a proton from here. So the correct option will give a double bond to keep all the centers stereochemistry same. It will give a double bond here. Rest stereochemistry of this rest carbon will be same, so I am not drawing it. Okay, all this carbon will be same. The next step, what will happen? So in presence of MCPPA, this iodine will be oxidized. So see, this sulfur can't be eliminated. So this iodine will be oxidized. Still take a proton here. Okay, what will happen? Okay, let's go to the next question. So next is Chugev elimination. It is same as the ester elimination. Just instead of ester, we will use thioester. Just instead of ester, we will use a thioester. This is a similar type of EI elimination. So the Chugev elimination is a chemical reaction that involves the elimination of water from alcohol and produce alkene. The intermediate is a xanthate ester. The intermediate is a xanthate. So here the OH will be converted to a xanthate ester, and after that it will undergo a thermolysis or elimination through a EI type of elimination and give us this alkene as our product. And a similar type of mechanism. So the mechanism is drawn here. So similar type of mechanism will take place and it will give us a alkene. So what will be the product in two cases? The reagents are same. What will be the product in these two cases? I just give 2 seconds, just think about what will be the product in these two cases. So what will happen? So it will take this in presence of potassium, which will lose the proton, and its O minus will attack to this CH2. Then after that it will be methylated. So the will form so it will be methylated after that. So it will form a sugar-based xanthate ester. So from here you can see this hydrogen and this ester is in the same plane, so it will undergo the seal elimination. So the correct option is methyl and phenyl will be in the same plane because both are above. So this is the correct answer here. That is a E alkene. But in this case, after the formation of the xanthate ester, the form a xanthate ester. After that, this will attack here. This comes here and so it is a Z alkene. Next is exchange motion fragmentation. By this way, we can generate an alkyne from a ketone through cleavage. So it is a conversion of alpha beta epoxy ketones to acetynylic aldehyde or ketones using para-toluene sulfonyl hydrogen, employing bases pyridine, sodium bicarbonate, etc. The reaction is generally known as the exchange motion fragmentation reaction, also known as the exchange motion Danabe ring cleavage reaction. So this is the mechanism where first this hydrogen nitrogen will attack to this carbonyl group and it will open up. After that, through elimination of this OH group, it will form this hydrazone and in the next step, when this proton is abstracted through elimination of a this electronic movement will break this epoxide bond and this O- will again takes place here, and through electronic movement it eliminate N2 as the byproduct and form this acetynylic aldehydes or ketones. So based on that, there are some questions. What will be the product in these two reactions? What will be the product in these two reactions? So obviously it is after, as I am discussing after exchange motion reaction, so this is based on exchange motion reaction. So what will be the product? So I am drawing the first one, then we will solve the next one together. First, in presence of H2NaOH, this double bond will be undergoes epoxidation, because we know that in case of H2NaOH, the alpha beta unsaturated double bond can form epoxide. After that, in presence of NH2OH, hydrogen, after that it undergoes exchange motion type of reaction. So the correct option will be I'm just keeping a step jump. The correct option is this is our next is this one. So I'm just doing a step jump. If you do a step by step, you can get an idea. This will be the product here. If you just draw this by yourself, step by step, you will get that product. It will be the product. Okay. So these are two questions. I have already solved this for you. So it's a similar type of question. So instead here, between these two double bond, as we know, H2 always undergoes epoxidation of electron deficient double bond. So these two double bond, the lower one is more electron deficient, so it will undergo epoxidation, and after that it will form this exchange motion cleavage reaction. And in the next one, between these two double bond, which one is, so they have given MCPB as your epoxiding agent. So we know in presence of MCPB, which double bond get epoxide? From the epoxide, the electron rich double bond. In presence of MCPBA, always electron rich double bond. In presence of H2O to NaOH, always electron deficient double bond. That's why the other double bond will be epoxide, from the epoxide, and undergoes exchange motion type of cleavage reaction. What will be the product in the following case? They have given multiple steps, multiple reagents. What will be the product? What will be the reagent combination to get this as our product? We get this as our product. So what is the difference? There is a OH group, but there is no such OH group is here. Rest is same. So if we can just eliminate the OH group, then it will be okay. So if we eliminate the OH group, there will be a double bond here. So at the end you have to reduce the double bond. At the end you have to reduce the double bond. The first one is the Chugev reaction. So Chugev reaction will give a double bond here. And in presence of Bu3SNH, in presence of I2PPS3-imidazole, that means it's a apparent type of reaction. So there the OH group will be just substituted by iodine, and after that in presence of hydrogen palladium, that will undergo the reduction. That is not possible here. So the correct option here will be option A. The correct option here will be option A. First, it will undergo the Chugev elimination to form a double bond here. After that, if you add the Bu3SNH, this double bond will be get reduced to give us this as our product. Next one is this one. What will be the major product form in the following reaction sequence? So this is from the reagent combination. First the epoxidation, then the tosyl hydrazine. That means it is a Western motion reaction. So if you draw the product, after the first step it will form this epoxide. If it undergoes a Western motion type of reaction, we form a keto group here and a triple bond at this position. The next step, if you add this Lindlar catalyst and H2, it will undergo the partial reduction, and that reduction is always seen in manner. So the correct option will be the difference between this double bond, and there is 4 carbon difference, that is 1, 2, 3, 4, and the reduction will be seen in manner. So the correct option is option B. Instead of Lindlar catalyst, if Barch reduction reducing agent is given like the lithium ammonia, then the product would be this one. But as Lindlar catalyst is given, so it will undergo the same reduction, that means this one. Okay, so just by changing the last one, you can change the product. If you add the Barch reduction, it will undergo the trans reduction, trans alkene, and if you use the Lindlar catalyst, it will give a cis alkene. What will be the major product form in this following reaction? This is also kind of a EI elimination, so it will be oxidized. Now, which is seen to this group? This selenium group is seen to this hydrogen, so hydrogen will be eliminated, giving this as our product. So the correct option is option C. I am doing the step jump. If you do it by yourself, just draw it on a pen on paper, you will get an idea how I am going in the answers. What is the major product form in the following reaction sequence? What will be the major product form in the following reaction sequence? You draw it step by step. In the first step, ethyl acetyl chloride is given, so it will be acetylated. This large group, I am considering it as R. Okay. So this will be acetylated. The next step, LDA is given in minus 78 degree temperature. There is an LDA. It will take a proton from here. answer is 3 plus. What will be the major product formed in the following reaction? What will be the major product formed in the following reaction? So in the first step, as zinc is given, it will undergo a zinc incorporation into the carbon-bromine bond. Next step, so then next is will be in place of MCBB, it will be oxidized. oxygen bromine zinc bromine form will be there, but it will be just photonated after the next step. So the correct option it will be undergoes a, because there is a seen hydrogen, so it undergoes a elimination and this bond will also break. So the correct option will be option B. Correct option will be option B. This is the last one. What will be the correct sequence for forming this one as our product? What will be the correct sequence for forming this as our product? So how we can plan the retrosynthesis of this molecule from this one? So first, if we just cut from this group, so this is similar to our substrate. So how this is possible? If we perform Wittig reaction, there is a possibility of Wittig formation of this step, but we want to Wittig formation of the ester. So for that one, we will just protect the aldehyde group. We will just protect the aldehyde group. After that, for Wittig, hydrogenation, for olefination of this ester, we usually use Tebe reagent, not the Wittig, because Wittig is limited for aldehyde and ketone. So we'll use this Tebe reagent. After that, if you add this, then after that is this OIT will attack through this CH2 to this group, and through elimination of water, it will form this alkene. So the correct option is option A. I hope you understood the. So if I draw, you have to. This is the forward synthesis. This ketone will be protected first. Using glycol. In the next step, by using Tebe reagent, the ester will be olefinized. Then OIT will comes here, and this CH2 will attack to this oxygen. It will open up, and through elimination of water, it will form this as our product. Okay, I hope it's clear. I just gave too much step jump, I think. The next step, In the next step, if you add H3O plus, this will be protonated and eliminated as now in presence of base. They attack to this ethyl group and break this carbon oxygen bond and utilize the oxygen. So the correct option is option A. Okay. So thank you everyone. So this is the overview of today's class. We have discussed about some important reactions of olefins and some other reaction to formation of olefin, followed by Chugev reactions, Eastern-Mosher reactions. Then we solved some questions based on that. So thank you. Have a nice day.